5 and 8? 3, 5, and 8. All right.
1, 2, 3, 4, 5, 8. 1 through 12.
All right, number 3 was the absolute value of x plus 5. So first thing I need to do is find my vertex, yes? Yes, that's right. Good. So I'm going to start with setting only what's in the absolute value equal to 0 to find my vertex. So this one's easy because there's nothing else in there but just x. So when x is 0, what is y? 5, right? Are y'all tracking with me? Now I need 2 up and 2 down. If I plug in -1, the absolute value of -1 is 1 plus 5 is 6. Plug in -2, the absolute value of -2 is plus 5 is. Same thing with 1 and 2, and you should get 6 and 7. So knowing that 0, 5 is my vertex, let's plot all these points. 1, 6, 2, 7. Same on the other side. 6, 2, 7, and then connect. How about the domain? Negative infinity to infinity. How about the range? Bracket 5 to infinity. You got that? Good. Which other one did you say? That was 3. Heard 4 and 5. All right. 4. I'm assuming it's the first 4. Because we did the second 4. This one was confusing because the vertex didn't sit at a whole number, but that is okay. So as I find my vertex, I have to set what's in the middle equal to 0. And then I solve it for x. So subtract 2 and divide by 3, right? Which would be -2/3. So as you set up your T-chart, this is the hardest one, and it's -2/3. Okay? If you plug that in here, of course you get 0. But now I need to go 2 up and 2 down. And you're not going to get the same values because they're spaced differently apart. But I would probably use -1, -2, and then I'd probably use 0 and 1. If you didn't use those points, if you used other points, it doesn't matter. As long as it's 2 points to the right and 2 points to the left. It doesn't matter which ones you use. They are spaced differently, and because they're spaced differently, what's going to happen is when you graph them, there'll still be points on that line, but you won't get the same values here for -1 and 1 and 2 and 0. There'll be different values, but it'll still be on that line. So let me show you what I'm talking about. At -1, 3 times -1 is -3. -3 plus 2 is -1, and the absolute value is 1. How about when you plug in -2? -6 plus 2 would be -4, give you +4. How about 0? 2. How about 1? 5. Okay. So this looks a little bit different than what you've been doing, but it's okay. So I've got -2/3, 0. This is going to be my vertex. Now I've got -1, 1, -2, 1, 2, 3, 4, 4. I've got 0, 2, and I've got 1, 5. So when you connect them, they're still, if I had graph paper, mine would look a lot better. They're still on the line. It's just different points that you're using on that line, but it still works. They're just not, see how they're not directly across from each other like the ones we've been doing? That's why. That's why you get different values. How about the domain? Or the range? Is that better? Oh, what? Not 0 in for x, set what's in here equal to 0. So subtract 2, and then divide by 3. Yes. 2 above and 2 below. Yes. If you don't, you just end up with a straight line. You don't get the curve in there, or the flip. What else? 5 and 8. Number 5. 5, here's why 5 was confusing. You got this negative that sits out front, right? So what this negative does is it says whatever you do inside here, the absolute values are making them positive, right? But then you have to take the negative of it after you do the absolute value. So what's going to happen is every single number coming out of here is always going to be negative. So let me show you what this looks like. Where's my vertex? -1. If x plus 1 equals 0, that means x is -1, right? Are you with me? Whatever is in the absolute value, you make it equal 0 and you solve it. So if you set it, so you like literally just put equals 0 and then solve it for x. So straight 1 from both sides. Get your -1. If I plug this back in, I get 0. Now go 2 up and 2 down. -2, -3, 0 and 1. If I plug in -2, -2 plus 1 is what? -1. The absolute value of -1 is 1, but now take the negative of that. -1. I understand why this one was confusing for sure. If I put -3 in here, -3 plus 1 is -2. The absolute value of -2 is 2. Now do the negative of it. 0 plus 1 is 1. Absolute value of 1 is 1, but now make it negative. And then same with 1 becomes -2. This one looks a little different because it should be upside down. That negative in front makes it go upside down instead of right side up. So I have -1, 0. I have -2, -1. I have -3, -2. I have 0, -1, and I have 1, -2. What's the domain? How about the range? There you go. This time it opens down, so the lowest it goes is -infinity, and then it goes up until you hit 0 and it's done. It doesn't matter, you have to start smallest to biggest. So the smallest is -infinity up to 0. It goes down forever. Number 8. F of x equals, here's your piecewise. This is when x is less than or equal to -3. These should all be easy except for that first one. So let's think about the first one because it's the absolute value. I need to find out. Think about the way an absolute value looks, right? Depending on where I cut it off, I may or may not have the V for it. In other words, if this was my cutoff point and I wanted everything bigger, it would just look like a piece of a line. But if this was my cutoff point and I wanted everything smaller, well, it would look like an absolute value. So I've got to decide, is my vertex within this region or not within this region? So the first question I'm going to ask you is, what is your vertex here? The x value of your vertex. What is x? 0. Right? You put what's in the absolute value equal to 0 to find the vertex. You agree? Now my question is this...
Hello. The formal presentation will begin in a few minutes. A recording of this induction ceremony will be available through the online School Connect community following the ceremony. Your experience here at Southern New Hampshire University is important to us.
How did it do that?
So why did it just start?
I don't know. Okay, so my question is this 0, does it meet this requirement? Is it less than -3? It's not less than -3, right? So I'm not going to graph my vertex. Do you understand why I'm not going to be graphing my vertex? If my graph, this one, is going to look something like this. But my cutoff is -3. So I'm going to be here at -3, and I'm going to be this portion of my graph. So it's not, none of this is even going to apply. Does that make sense to you on why it's not in there? Okay. All right, so I can just use that plug-in method is what I'm getting to here. If I plug -3 in, what do you get? 2. -3 times 2 is -6. Absolute value -6 is 6, and 6 minus 4 is 2. So I have -3, 1, 2, 3, 1, 2. And it's a closed dot, right? Your Friday recycling. Pick an x less than -3. No, I just sent you that picture. Pick an x less than -3. -4. If you plug that in, what do you get? +4, right? 2 times -4 is -8. Absolute value of -8 is +8. 8 minus 4 is 4. Do you see why the vertex did not matter here? If I continue to, do you see it, Dylan? You know why? Why? If I continue to graph this, the vertex would be like, right, none of that matters because it's not part of the graph anymore. All right, that's this portion. Look at the second line. When x is -3, what is y? -5, because y is always -5. It doesn't matter what x is. So 1, 2, 3, 4, 5. It is an open dot. When x is 2, what is y? -5. Just like that. And then the last one, when x is 2, what is y? 0. Say it quietly. 2, 0. It is a solid dot. Bigger than 2, so maybe 3. What is y? And now domain and range. What's the domain? How about the range, though? -5. The range? What about this piece? That's the -5. Then it skips. That has to do, you're talking about this on the -5? These are both open, but that's going to impact the domain. But since it's open here, but can y be -5 is my question. Yes, because here it actually is. You're looking across. You're looking a different way than what you look with the domain. So range describes y. Can y actually be -5? Yes, and that's why I need the bracket on it. And then it skips, so I'm bottoms up, right? So that's the lowest it ever goes, and then it skips all this, and it doesn't pick back up until I get to 0. And then it goes up forever. Domain and range is still a struggling point, isn't it? All right, let's take a little break in between. Specifically, absolute value inequalities. There are two differences when you graph absolute value inequalities versus regular absolute value. One is going to be a solid versus a dashed line. Okay, that outlines the graph itself. So if I'm in a situation where it's less than or equal to or greater than or equal to, I'm a solid line. So looks something like this. I would write either or, doesn't matter. And if it's a dashed line, if it's a less than or a greater than, then I'm going to actually dash the absolute value graph itself. Make sure as we go through these packets this way, guys, that y'all are keeping up with them, because as we get ready for tests and exams and things, you'll want to make sure that you have something to study. Got so much money, it's just falling out. Must be nice. All right, the other thing that's different is the fun part. We're going to have to shade, and we're going to have to decide where we need to shade depending on what the symbol says, okay? So if I'm in a greater than or a greater than or equal to situation, if I open up, I'm going to shade inside the parabola. And if I open down, I'm going to shade outside the parabola. Because greater than, I want to go the way it goes up. Then if I am less than or equal to, depending on which way my graph opens, I'm going to shade outside if it's less than this way, and inside if it's upside down. Now, one thing, you can always test a point. Every single point where it's shaded should make the equation or the inequality true. And where it's not shaded should make it not true. So I'll show you how we do this. We'll start with number 1. F of x is less than x plus 1. So, two things. First of all, is it going to be solid or dashed? Why? There's no line under it. That's exactly right. And because it's less than, I'm going to be shading down wherever it is, okay? So everything else is exactly the same. I'm going to do my table of values just like I did before. I'm going to find my vertex just like I did before. It's just those two things that are tacked on here also. So where is my vertex on this one? -1. That's exactly right. -1. 2 up, 2 down. And it's 0 at the vertex. If I plug in -2, -2 plus 1 is -1, and absolute value of -1 is +1. Plug in -3 plus 1 is -2. Absolute value of -2 is 2. How about 0? What's the y value? And how about 1? 2. So let's graph it. Let's plot the points first. -1, 0. So here's my vertex. -2, 1. -3, 2. 0, 1. What's wrong? 1, 2. And we said it's dash, so I'm just going to go ahead and dash it in. So it's shaded down. That's exactly right. So where is that? Is that outside the absolute value or inside? Outside. Outside's going to be down. So I'm going to shade outside. Notice what's missing on these problems that you had on the other problems. Domain and range. Domain and range, because these have a lot of values that are included. Does this make sense to you? It's pretty easy. It's just a build on of what we did yesterday. Yeah. You can just shade enough to show that. I'm not going to spend a very long time on this because it is exactly what you did yesterday. When you get past 1 through 6 and you get on the back page that goes 1 through 10, those are mixtures of equations and inequalities. So make sure you look at what it is you're graphing. Remember how I told you from now on we're trying to kind of build on, include things that we've done in the beginning so it's not such a shock on a test whenever you see everything all together. So that goes through the absolute values, the piecewise, and the inequalities. Okay, so make sure you look carefully at what it is that you're graphing. But if you don't need any more examples, because I know this, I planned on doing this yesterday with the equations, but that's okay. It was my fault. And this will give you a good thing to end the week on without something new and terribly hard. So this is homework. We'll call it classwork homework. You have almost an hour to work on it.